In this lesson, we want to find the axis of symmetry of a parabola. This will help us to make a more intelligent table of values when we set up the graph. Having memorized the quadratic formula gives us an additional piece of information as we graph our parabola. Remember that the quadratic formula x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It turns out the equation of the axis of symmetry is exactly x equals negative b over 2a, which is found in the quadratic formula. Let's look at some examples. Y equals x squared plus 4x minus 3. Our equation is in standard form. A has the value of 1, b has the value of 4, c has the value of negative 3. Our axis of symmetry is negative b over 2a. Negative 4 over 2 times 1 gives us negative 4 over 2, gives us negative 2. So x equal negative 2 is our axis of symmetry. If we put a mirror on the line x equal negative 2, the left side and the right side of the parabola would be exactly the same. This also tells us if we're going to have 5 values that we should put negative 2 in the center. If we increase by 1, decrease by 1, from there we can find each of the values that goes into our table. Using our graphing calculator, we can find the values, and you will notice something interesting happens as we complete these values. Notice at x equal negative 2, the axis of symmetry, we have a y value, but there's a symmetry about if we go 1 to the left and 1 to the right of that x, our y values are symmetric. Also notice if we go 2 to the right and 2 to the left, and this will happen each time. Let's try the equation y equals x squared plus 7x plus 12. We have our a, our b, and our c. The axis of symmetry is negative b over 2a. Negative b would be negative 7 divided by 2 times 1, which gives us negative 7 halves. So x equal negative 3½ is our axis of symmetry. So if we put our middle value for x, negative 3½, if we added 1½ we'd be up to negative 2, and if we add 3½ we'd get up to 0. If we subtract 1½ we'd get to negative 5, and if we subtract 2 more it'd be negative 7. So with that in mind, and we're using our graphing calculator, we can get the values of y are 12, 2, negative 0.25, 2, and 12. Once again, when we look at the x value of the axis of symmetry, we get our value, but there's a symmetry about the y values because we're looking at both sides of the parabola by using this as our central point. Let's try this one more time. We have our a value, our b value, and our c value. The axis of symmetry is negative b over 2a. b has the value of negative 12. a has a value of negative 1. So we have x equal to negative 6 is once again our axis of symmetry. So if we put negative 6 in the center, we go up by 2's, we go down by 2's. If we take our graphing calculator, we can find the y values: 33, 45, 49, 45, and 33. Once again, our x value for the axis of symmetry is the central location. Notice our y values are evenly dispersed around the two sides.